Hi, I'm going to introduce you the approach in linear programming application in agriculture decision making. The LP technique is relevant in optimization of resource allocation, achieving efficiency in agriculture productivity. The general background of the first example is that agriculture contributes to nearly 25% of Indian GDP and 70% of Indian population, which is dependent on agriculture for their livelihood. Researchers believe it is vital to determine the optimal land allocation of food crops. Researchers collected data from government officials at Srinagar from period 2014 to 2011. After that, the authors set up the objective function as the output of agricultural productions and food crops with constraints of labor hours, working days, land size, and capital per acre. Through comparing to other algorithms, researchers found that simplex method has been the most efficient way to solve such linear programming problems. The result shows that the maximum profit that can be achieved is 1376 million, which is more than the predicted in the first season. The example shows that LP can help farmers determine how to increase the production of crop per unit, which is extremely beneficial for a developing country like India. In the second example, a study was carried on to study land allocation in a special area, which is the saline tract. In saline tract, the soil and water are saline and make it not suitable for irrigation, so the agriculture there depends on the monsoon. Malta is a part in India located in saline tract work as a special case in this example. Due to the climate and environmental conditions, agriculture in study area mainly has two seasons of agriculture in a year, which are June to October and October to April. Thus, the decision maker who want to maximize profit need to find optimal land allocation during the two seasons. There are several constraints, including cost of seeds, the constraints on usage of area in two seasons, etc. The author applied a linear programming model to solve for land allocation plan to the major crops, finding this model is appropriate for the spatial saline tract. Finally, let's look at application of an extension to LP. GLP deal with the conflicting goals which are common in agriculture. GLP stands for goal linear programming. For example, crop and production water requirement. You want to increase production, but there's limited available amount of local water. You also have essential constraints that simply cannot be violated, such as land availability. What GLP does is add punishments to violation of goals. U1 and U2 here is measuring how far you are from reaching the goal, and decision makers assign violation with weights, D1 and D2. That's how much they value the goal. It could be financial cost or other social factors in play. Then the objective function becomes minimizing total punishments with everything else in the constraints. One case study done using data from India showed that GLP outperforms single objective LP when there are conflicting goals. To conclude, our report and three real-life examples show LP is one of the most efficient tools to solve agriculture prediction. It is flexible in that unique regional factor can be included in the model, and its applicability is limitless since it can take on variations. Thank you for watching.